So here we have a related rates problem, number 45 on page 218. We're finding the rate of change of theta given at this partial angle here at x equals 30 as our x value is increasing at a rate of 3. We're taking it at x equals 30, and our a and b values given here and here are both constants in this case. So our first step is to establish the relationship of these angles, that the whole angle minus this partial angle towards the bottom is going to equal the remainder, or the theta that we're calculating. So what we're going to do is set up a relationship given tangent relating the adjacent or opposite over adjacent of both b and a in relation to x. This step is done with the arctangent of the a value over the x value minus the arctangent of the b value over the x value. The result of these two tangents is these given angles. So the subtraction of such should give us theta. Now when we take it as a derivative with x expanding, we use our chain rule, and within this a over x, we have to use the quotient rule of a prime x minus x prime a over x squared multiplied by the derivative of the arctangent 1 over a over x squared plus 1. We do the same method to the second arctangent, only with b in place of a. Now this, in turn, equals theta prime, having taken the full implicit derivative of the equation. Now we plug in our values, 30 for x, and 0 for a prime because it's a constant, and 3 for our x prime because that's the given rate of the expansion of our x. And same thing given in here, 10 for our a value and 30 for the given x value. Quantity squared plus 1 over 1. Same thing happens here, as the rate of change of b, it being a constant, is 0, multiplied by the x at our given time, subtracted by the x prime multiplied by b, all over our x squared, and our same arctangent function, only with the b in place of our a. We can do some simplification and multiply these out to result in negative 30 over 900 times 9 over 10 minus negative 9 over 900 times 100 over 101. This still equaling theta prime. Further simplification results in negative 3 over 100 minus negative 1 over 101. Finding the common denominator of these, multiplying them both by each other, and then doing the same to the numerators, we get a result of negative 203 over 10,100, equaling theta prime. To further simplify that, we result in the decimal of negative 0.020099009900, and so forth. As an approximation, this being in radians per second, as given in our x prime in the written text.